Welcome to llmfit, the terminal tool that automatically sizes large language models to fit your computer's memory, CPU, and GPU. llmfit scans your hardware, evaluates every model in its catalog across memory fit, speed, quality, and context, and tells you which ones will actually run well on your machine. You can use llmfit through an interactive text-based user interface or a classic command line. The interactive interface defaults, but you can also run commands directly. llmfit fit shows a table of all models ranked by how well they fit your hardware. llmfit recommend outputs the top picks in JSON format for use in scripts or agents. llmfit info followed by a model name provides a detailed fit analysis, the assumptions behind the estimates, and how to verify them on your system. llmfit bench measures real token throughput and response time against your chosen provider. llmfit doctor gives a hardware detection report useful for troubleshooting. If you prefer Docker or Podman, pull the image named GHCRIO AlexsJones llmfit. Running the container with a TUI flag launches the interactive interface. With a recommend command you can pipe the JSON output to a tool called JQ and extract just the model names you need. Installing llmfit is straightforward. On Windows, use scoop with the command scoop install llmfit. On Mac OS or Linux you have several options. With Homebrew Run Brew install AlexsJones llmfit, which installs a pre-built binary that works on all versions. If you prefer Source, clone the repository, build with Cargo, and run the binary from the release directory. There is also a quick install script you can pipe to your shell to download the latest release directly into USR local bin or .local bin. For Python users, llmfit can be installed with pip as a tool or package. Mapping out how llmfit works, it first detects your hardware including RAM, CPU, GPU or VRAM, and which provider backend you're using. Then it scores every model in 4 dimensions, how many parameters fit in memory, an estimated speed based on a memory bandwidth model and real community measurements, quality metrics, and context size. The speed estimates are backed by actual runtime samples, and every estimate includes the inputs it was based on, so the info command lets you verify the assumptions on your own machine. Contributing new models or improvements is welcomed. Before submitting a pull request, run the Rust formatter cargo fmt. Failing the CI often means your code isn't formatted correctly. Guides for adding custom models are available, explaining how to extend the built-in catalog without rebuilding the entire tool. If you're after a different approach, consider llmchecker, a Node.js command line utility that integrates with llm to pull and benchmark models directly on your hardware. It focuses on real-world performance rather than estimations, but it doesn't handle mixture of experts' architectures and treats all models as dense. On Windows, llmfit binaries are digitally signed by a commercial kata signing service. The signing process happens automatically in the release pipeline and is only applied to artifacts built by the repository's continuous integration system. The software respects user privacy. It only contacts external services when you explicitly use features such as downloading models, querying a runtime provider, or accessing the community leaderboard. Finally, llmfit is released under the MIT license, which allows you to use, modify, and distribute the software freely. Enjoy discovering the best local large language model for your machine with llmfit.